Hi, this is 102. We're back at it again. This time, as you can see, we're turning our attention over to the opportunities in crop production systems, the future, perhaps, of crop production systems. Again, we worked with Cameron Pittelcow from our crop sciences department on this. Let's get to it. So, there are lots of ways, for considering the future of crop production systems. Here is a snapshot of some ways that Cameron organizes his thoughts in this particular area, and indeed it reflects a number of different aspects of our systems thinking process. I would encourage you, if you want to think about this further, post some comments, and we'll see about trying to get you some feedback on this. Send us an email. You saw Cameron's email on the front page here. I'm sure he'd be happy to get back to you too. So don't hesitate to find different ways to contact us so that we can try to help you out. But if you're seeking to improve crop production systems, there's loads of ways. The Danforth Center has put together a big list here, all for crop production systems. They've published them. Go find it on their website in order to try to find different ways in order to improve crop production systems. There's loads of ways, and we've talked about them already. If you're looking for any additional details, come back to this video, zoom in on any portion of this page, or ask me some questions so I can get you the slide directly. Here's the outline we're going to go through today. In this portion of the video, we're going to get through here. We're only going to get through some developing world issues in particular. The video I'll post tomorrow will hit the remaining bits on this particular page. Genetic modification versus management. So leading up to today's presentation, we did talk about applied biology and active management of the environment that the crops are growing within. What if we leverage biology even more? Well, that's what genetic modification is really about. How can we bring what we understand about biology in order to improve the underlying biology of the species you're dealing with at any given time in order to improve its performance? And that, of course, that makes sense. If there's really two tools that we're wielding, whether it's biology or management, one of those two needs to improve, you might say, in order to improve our systems. If you go back to this list here in the Danforth Center, many of these are about management. Drip irrigation, sprinklers are two different forms of irrigation, changing the environment. No-till versus organic. Again, two different ways that you might manage the environment in order to leverage the biology. Well, the other alternative is the biology itself. What are some things that we're targeting in biology? Adding genes, maybe many different genes that control different functionality in the crop in order to provide tolerance for pests, or more specifically, tolerance for the pesticides or herbicides that were utilized in order to target the pests or the weeds that are attacking your plant. Other things, items 2 and 3 on this list, improving the ability of the plant to use nitrogen. That would eventually, you might presume in the future, extend to other nutrients, or improving the ability of the plant to deal with drought. What's the underlying assumption there? By targeting these different things, we have to have more grain in order to increase calories, access to protein. The quality of the diet, however, is not really considered here. Vegetables are really important, aren't they? We've recognized that. You guys have talked about healthy diets. But the fact of the matter is they are farmed considerably less. In truth, those types of crops have considerably smaller environmental impacts. I think, however, in this discussion, these are assumptions, by the way, for this discussion in general. Monocropping is here to stay. We are going to have a great lecture in the next few weeks about polycultures utilized on our landscapes. But the truth of the matter is, those things, are they going to compete well against monocropping? Monocropping, of course, especially on really fertile lands, is very profitable. I guess the underlying assumption here, at least the one put forth by Dr. Pittelcow, it's not going to compete well against monocropping, not soon. Maybe in the future, but not soon. So rather than some of these big changes, changing our diets, changing our cropping systems wholesale, let's focus on some of the many smaller achievements that we could use to increase our crop productivity. Individually, they're not revolutionary, but you put them together, they could be pretty big. It's important to keep those projections in mind. More food is necessary, maybe double. Where is it going to need to come from? Who needs to increase their productivity? Both of these charts are projecting out to 2030, which is really not that far away. Where does the increase need to come from? Well, the demand for food needs to match where the increasing demand is going to come from. So that's what's on the left side. Calorie consumption has gone up, will go up, and is projected to go up in all around the world, especially in developing countries, of course. Africa is going to eat more, you need to say, for a chart like this. And that being said, food demand on those continents goes up with it. If you're looking for some ideas for some additional reading, a lot of that is supporting this discussion here. Look for the Food First page. Some good reading, fairly well balanced reading. Now that being said, the challenge is great, yes, but it does seem that investment dollars, venture capital dollars are coming in to take a big portion of that opportunity, or at least give their best go of it. This is recent data up until 2014. You can see that both the amount of funding being brought in 2014, there's an estimate in there, of course, but I think that estimate's not bad. I'll show you some examples in the next couple slides. Is going up, so the dollar value of the investment in agriculture going up, as well as the number of, that's the volume, the number of deals is increasing. And the reasons are many. The reasons are many, but possibly this is a greater attention to the impacts on our environment due to the current system. On the left, an article, New York Times, concerns about weed killer on the impacting on the soil. On the right, a view of a nutrient management plan for watersheds that are impacted by agricultural fertilizers and other chemicals. So the public concern, the take-home message here is the public concern is increasing, as well as the potential for new regulations coming down the pipeline, which is being depicted on the right. So the question we always have to ask ourselves in situations like these, if we need to intensify or increase our productivity in our agricultural system, we don't necessarily know or fully understand where the tipping point is as we move to the right, from the left to the right in this particular chart. You might take the viewpoint that we are moving along this curve, okay, which suggests that we're already at the tipping point right here and now in our current agricultural system, and if we intensify, biodiversity and ecosystem services should suffer or may suffer. Or do we have some range, the top curve, where we can impact systems, disturb systems into the future without any major loss? We don't fully know or understand. Many would say, the Environmental Coalition might say that we're on or already on the down tilt along the red curve. Okay? A multifunctional agriculture in our future would hopefully put us up, push the red curve up onto the green curve, though. Okay? The question then is, look, if you're going to try to increase yields while avoiding impacts on the environment, well, where are those opportunities to do so? Well, according to this article here, and anybody's looking for an article, let me know. We'll try to find a way to get it to you. Most of them are marked on the slides. You may be able to find them, but you may need to go. You may need some help in your digging. Uh, uh, the colors here, as you go to the right, you're reaching 100% of the possible yield being attained. Okay, and it's notable then, right? Western Europe, where we are, Central North America, very green, if not quite yellow, meaning that the possibility of achieving maximum yield, at least according to this study, is pretty good for these particular crops: maize, wheat, rice. Areas which are hungrier, or areas with utilizing fewer inputs, are not quite so. And indeed, many of those regions are also the regions where people are the hungriest. Okay, so you've heard that story or stories similar to this, or stories that support these concerns elsewhere as well. Okay, and this is all controlled, as a reminder from the previous presentation, by the law of the minimum. Something about those environments is not sufficient and is limiting yield. What could it be? We don't know. It's going to be unique in each case. But we have a similar discussion then of items, maybe it's several of these, that limit the actual yield relative to the potential yield. And that's what we end up calling the yield gap. So many of those things, that, and probably several of them compound, even in the best systems, but definitely in the developing world, or in those areas, the red areas on this map. Okay. Closing those yield gaps then becomes one of the key objectives for agriculture in the future, particularly crop-based agriculture. So how do we do it? We're going to focus on soils, improving those soils. Many of those nutrients came from the soil ultimately. We are seeing degradation in a number of different areas. And we want to make sure that in order to avoid both the degradation, to avoid the degradation and improve soil management, make sure that we do have access to those inputs in order to replace those nutrients. And finally, the people who need the most help are probably those poorer smallholder farmers in the developing world. Conservation agriculture helps us do a number of these things. This involves three key issues. Some of them are regularly applied in our area. So they should be of no surprise. We would like to see them adopted in other areas. In order to preserve the soil, minimize tillage. Okay, keep the soil as protected as possible, utilizing the residue to protect it. That's item 2. And in order to improve the quality of the soil, will involve some crop rotation. I'll talk about that in a moment. Okay. And there's many different benefits, potential benefits listed here. In order to, that would all be of a benefit to the cropping system. So let's see which ones we can achieve. Okay. First and foremost, then, the crop rotation. We can't always be focusing on any given crop, especially grains, those that are the most taxing or extractive of nutrients onto their system. We need to bring in some legumes. And we've historically often rotated legumes in with cereals. Why is that? Here's the biology part. These legumes have a symbiotic relationship with nitrogen-fixing bacteria in the soil that are naturally occurring in the soil, and they form root nodules. That's these little lumps that you're seeing here throughout this root system. And because of that environment, the plant itself is now providing an environment for those bacteria. Those bacteria then fix nitrogen and make it available to the plant. Some, by the way, stays behind in the soil. We'll talk about that in a moment. Okay? So it's symbiotic. It's most common in legumes. There are other forms of this symbiosis that occur. These are probably the strongest known relationships. And they leverage specific enzymes, the nitrogenase enzymes, in order to cause that reaction to reduce nitrogen gas to ammonia. Now, it's not a free lunch, however. That process is energy intensive, and rather than producing as much biological yield, carbon yield in plant matter. It makes this fertilizer instead, and that is a major trade-off. So you don't get as much total mass of material in the plant. But with a legume, you can avoid hundreds of pounds of nitrogen because of this symbiotic relationship. Here are some of those trade-offs then, depending on how you manage your system. Each of those 4 charts, and I'd urge you to come back and ponder this chart later on, because what's happened, these charts are very much like those dynamic charts we drew in our systems thinking process. Time is on the horizontal of each, but the difference in each of these 4 charts is the quality of the litter, or the residue materials that are left over on the field. So if we have high quality litter, a litter that is protecting the field, the amount of nutrient released here is really quite high, and this has now become available, and in fact exceeds the need of the plant for its uptake in nitrogen, in nutrients for its growth. So that would be a situation where that nutrient, nitrogen in this case, is not limiting the growth. The situations that you want to avoid are these that are labeled deficiency here and here. And effectively, these are scenarios where there's a low quality litter, or even no litter protecting the soil. So there's a key opportunity there. And that all comes through, of course, management strategy. So several studies have considered these systems, many hundreds of studies studying no-till systems and no-till yields. And it's not perfect for every situation, actually. What this chart here is depicting is that, according to all those studies, taking a number of different scenarios with a number of different rotations of different types of crops, actually in some instances having that litter in place can negatively impact yield until you start to consider the climate and the environment, particularly dry climates that might be limited in irrigation and or precipitation. Those are the ones that really benefit. These are boosts in yields over here past the dotted line. So there are certain areas, and the literature shows and supports that there are certain places that we really need to be thinking about this quite strategically. So it's not a perfect system, but there is potential, okay? And that's the lesson learned here. You can manage soil better, but not everywhere. In some areas, really, we might be doing as best as we can. Okay, so that limits the potential range of that potential outcome. So there's some additional challenges too. Even if this was a great way to go, let's not forget then there are additional challenges, or sorry, uses for that residue material on the field. I think most notably is that becomes good feed potentially for livestock, and that's an important part of many farming systems, and an important source of protein and other nutrients. But it also becomes a fuel, a solid fuel, something that is burned, especially in the developing world, for cooking, for heating, and would be something, a key need, an energy resource that would be competing against these things. You may need access to herbicide in order to be able to do this well, or lots of labor, which, as we know, is expensive. So that's not always easy either. There's potential for losses, particularly in early years. And I'll show you why in a moment, but it's important to note this one. Yes, you can do it. Yes, you can build better soil, but it's not a quick process. It may take on the order of years to really see the benefit. And therefore, especially under dry conditions, let's not forget that residue can potentially get in the way of the subsequent crop that's going to be placed on those systems. So remember, these are just some reminders. It could look considerably different. If you have lots and lots of residue, these are some, on the right-hand side, this potentially could obstruct the growth of a subsequent crop. It's not unreasonable to till it in. There are many systems out there that do it, especially not near here. Other options are if you need to get it out of the way, then you might burn it. Okay. But here's that slide that I mentioned. So there's a transition period of the quality of the soil over time again. You should, again, be familiar with charts like this. Presuming you're starting to leave it on the field, waiting for it to improve the quality of your soil, the first thing that improves on this first curve here is the carbon in the soil. And that sounds great, actually. At a time when we're concerned about climate change, if we could prevent it from being in the air and put it in the soil, that would be a great thing. And so you might want to think about that. But there is also a challenge and an opportunity, you might say, because it prevents moisture from moving back into the air as the material itself starts to aggregate. So water and nutrient holding capacity eventually start to increase, but there's a period of time where it's decreased. And then eventually we'll see water quality downstream from systems like these. And this is referring both to surface water as well as to groundwater, and finally productivity improving because of the higher quality of the soil. So this transition period is not trivial, and this is probably, I would say, not to scale. So, oops. Oh, and I forgot, that's actually our last slide for today. So let me just double check that, but I believe that it should be true. Show the sidebar. Yes. So we'll sign off here for now, and we'll be dropping another video tomorrow. Let us know if you have any questions.